1.3, solving equations. We have verbal expressions and algebraic expressions. We use these word expressions here. And plus sum, more than is addition. Minus, difference, decrease by, less than for subtraction. Times, product of, as in 1/2 of a number. Of is always used with fractions, and that is multiplication. Division would be divided by. Quotient, example 1, write an algebraic expression to represent each verbal expression. The sum of 6 times a number and 25. The sum of what? 6 times a number and 25. B, 4 times the sum of a number and 3. 4 times what? The sum. We needed to use parentheses because 4 needed to be multiplied to 2 things. The sum of what? A number and 3. A number and 3. These ones are tricky on C. 7 less than. That means minus 7. It has to be less than something else. What is it less than? 7 less than 15 times a number. The difference of 9 times a number and the quotient. So we have the difference. The difference of what? 9 times a number and the quotient, what means to divide. The quotient of what? 6 and the same number. 6 and the same number I used here. We have the difference of 9 times a number and the quotient of 6 and that same number. Problem E, the product of 3 and a sum. We got to be careful on that. So we have the product of 3 and something else. We're multiplying 2 things, 3 and a sum. Need those parentheses. 3 times the sum of what? 11 and a number. 4, problem F, 4 times the square of a number. 4 times the square of a number increased by will be adding. What is it being increased by? 5 times the same number. What number? The same number we're using over here. 4 times the square of a number. 4 times the square of a number is being increased by what? 5 times the same number. This same number. 5 times the same number. Again, anytime you hear less than or more than, problem G, that means plus 23. 23 more than a product. 23 more than a product of 7 and a number. Example 2. Now you're going to go in the opposite direction and you are going to write a verbal sentence to represent each equation. These can be different. Not everybody's going to say exactly the same words. But here I would say the difference of three times a number and the difference of 3 times a number and 35 equals 79. Here we have 2 times a sum. 2 times the sum of a number squared and 3 times the same number squared. Equals 4 times the same number. If we didn't clarify, we started with the sum of a number. That was the first n. If we didn't keep saying the same number, it could mean a different variable. That's why we said 3 times the same number squared equals 4 times the same number. That means n. Properties of equality. We have the addition and subtraction property of equality. If we have A equals B, that means that I could say A plus C equals B plus C. I added C to both sides, and the equation would still stay equal. Because I did the same thing to both sides, it's staying equal. Property of equality. I could also say if I had A equals B that I could subtract C from both sides. That would be the addition and subtraction property of equality. We use these to solve equations. We also have the multiplication and division property of equality. Again, if I start with A equals B, I could multiply C to both sides, or I could also divide by C to both sides, and it would still be equal to the original because I did the same thing to both sides of the equation. Multiplication and division properties of equality. Okay. On example 1, we have a 2-step equation because x is being multiplied by -8 and x is being added by a +10. Remember that we use PEMDAS forward when we simplify, and then we use PEMDAS backwards when we're solving. Is there any adding and subtracting to be undone? Yes, the 10. How do I move 10 to the opposite side? I need to do the opposite of 10. I need to do it to both sides of the equation so that it stays equal. 10 minus 10 cancels, and I bring down -8x equals 50 minus 10. I'm all done with adding and subtracting. Now I'm looking for any multiplying and dividing to undo. X is being multiplied by -8, so I will divide by -8 on both sides of the equation. -8 divided by -8 leaves a +1x. That is always the goal. We want to have x, and it needs to be positive. X equals 40 divided by -8 is -5. So we have x equals -5. Example 2, we need to solve for y. We have 2 variables in this equation, and they want us to specifically solve for a variable. So what's being done to this y? It's being multiplied by 5, and it's being added by 4x. It's the same as the problem that we did up above, except we're just trying to solve for y. We want to get y by itself. Again, I need to start by undoing any adding and subtracting. I need to subtract 4x to both sides of the equation. And we get 5y equals, can I combine these together? 100 minus 4x, are these like terms? No, they are not. So I would simply write 100 minus 4x. I cannot combine those together. Am I done solving for y? No. I still need to undo the multiplication. So I'm going to divide by 5, divide by 5, divide by 5, divide all the terms by 5, and we get y equals 100 divided by 5. What's 10 divided by 5? 2. 100 divided by 5 is 20. And how about -4/5? Is this going to reduce in the fraction? No. So we just leave it as -4/5 and put the x right next to it. It's starting to look like slope-intercept form. Remember that?